is a sequence. This is a series. This is called sigma, and it's a quick way of writing a series because series take a long time to write out, especially if, or sequences take a long time to write out, especially when you've got a lot of terms. Now sigma is very useful because it shortens a long addition sum down into just this terminology. Now you got to be able to understand it. What's the 7 refer to here at the top?
The number of until
yes, the number of times I substitute into the formula. That's that number of terms in the series.
What's this called?
Sigma notation, I suppose you could call it. It came up in this chapter because I put it up because I presumed it would be one of the questions you'd ask me. What does the k equal to 1 at? Mean?
K is 1.
Yeah, the starting point. I start with k equals 1. So you know when you have a series with nth term and stuff like that, you start by subbing in for n, you sub in 1, and then 2 to get the second term, 3 to get so on.
Why is it k and not n?
Yeah, good question. So I deliberately wrote the second one here. Deliberately wrote the second one with n, and then forgot I was doing that. What's the difference?
Nothing.
Oh, it's n for a sequence and k is for a sequence.
Nothing. There's no difference. It's just x and y in algebra. Now I know x and y will be on two different axes in algebra, and maybe a and b in algebra. They're just variables. Same here. It's just k's and n's are used a lot in sequences, whereas x, y, a, b, c's are used a lot in algebra. Sequences is part of algebra. Anyway. How do we then write this as a sum? Well, we start with 1, so that's the start number we sub into. This is the formula, or the nth term.
Why don't you have it on your calculator? Like
You do have sigma.
it's just because we didn't use it.
You just haven't used it yet. There's lots of stuff you haven't used in your calculator. You get to more this year and next year, and still you won't have used your calculator for probably a quarter of what you use. Alright. So what do we do? To start subbing 1 into that, again 1 squared. Then I sub in what next?
2 squared?
2, yeah. 2 squared plus 3 squared plus 4 squared plus 5 squared. Now notice I'm adding these up. This is what the series is about. This is what the notation says. To add up. 6 squared, where do I stop? 7. Why do I stop there?
This number.
There's 7 in terms. Yes. I've done 7. And I add up. You can do that. Okay, so that is the sigma notation is all about. We'll do the second example. So n is used in this case, but that's okay.
Well, will this give me the sums?
On a calculator, it'll give you some. Yeah, if you type it in, it won't show you this. If you do this on a calculator, it goes straight to this, which is 49 plus 36 plus 30, 25 plus 16.
But so if we get like questions above with some, do we use that?
This question asked to expand and hence evaluate. So we had to show this expansion and then add it up whatever way you want to add it up.
Isn't there a formula? Like the average multiplied by.
But you see, this formula is going to be different every time. So to add a sequence, you actually to do it personally, you have to look what the sequence is, what the series is.
Can you find the formula if you get a sequence?
Yeah, well, you've been doing that in GCSE. You found quadratic, cubic sequences, geometric sequences, linear sequences. You found them all. Like this, what type is this? It's a quadratic sequence. So you could find that formula. Your formulas were more difficult in GCSE. It was like k squared plus 3k plus 2 or 1 or something. That was your formula. You found them easy enough. But you need to have these answers first to go back. Anyway. Yeah, so this is actually quite simple terminology. It's used a bit more down the line in integration and stuff like that, but we're just getting used to the terminology here. So how many terms do I have when I do this? How many terms am I going to add together? 4. What's the first thing I'm going to sub in? 1. Yeah, it isn't always 1, but usually is 1. So this is going to give me 4 over 3 when I sub in 1, plus 5 over 4, plus 6 over 5, because now I'm subbing in 3, and the last one I'm going to sub in 4, so it's going to be 4 plus 3 to be 7, and 4 plus 2 to be 6, and then do some sort of adding there with a common denominator from each year.
Would NFK would not be 1?
It could, yeah, it could be not be 1, yeah. Yeah,
Why don't
just-
they just put the number next to the sigma notation, so it's like k and then k equals 1. Seems better.
Seems a bit overdone, too much.
Yeah, they could just straight away put 1, right?
In this case, it's probably not that useful to use sigma notation to donate a series. You could just say find the sum of the first 7 terms of k squared. It's easy to say.
So the sigma is the sum. of
Sum,
that.
yeah, you must add. Yeah. It's just another way of doing this S8. Or sum of the first 8 terms. Or this would be sum of the first 7 terms of k squared. It's another way of writing it. It's just a terminology that we have to get used to for further down the line. So it won't go any further than that really. Okay. Anything else to come up? You said there was a question that was tricky-ish, maybe?
23 on 5.
23. Question 23? There was 23.
Yeah, no, it goes to 10 and then straight to 20.
Oh, that's weird.
Yeah, 10 to 20.
Oh, this one goes and this one doesn't.
Yeah.
So, okay. The sum of it, oh, this one, okay, good. The sum of an infinite geometric sequence.
That's a theoretical sum, right? So
Yeah, of course, yeah, it's like 48.9.
Yeah.
But we delimited this. The sum, so we need this sum to infinity. We know that this is true, yeah? We can use this because it says sum of an infinite geometric series. That's what this is. It is 49, and the second term is 10. Find the possible values for the first 3 terms. Wow. Okay, so we know that u,
Wait, why are you doing u1 over 1 minus?
that's the formula for sum of an infinite geometric sequence. So I didn't, I just knew it, but I would go to my former booklet and look for the sum of an infinite geometric series. It's in there. Okay. So the answer to this, so u1 minus 1 minus r is 49. Okay. We don't know u1, but we do know the second term. What relationship does the first term have to the second term?
R.
Yeah, some or relationship. Well, what could I
So
say?
U2 minus U1 is R.
u2 is equal to
U1
u1.
R. Is it a geometric?
Yeah,
So
So
the
these
usage
10
times R.
times
10
R.
is R. U1 R.
The second term of the series is 10.
U1 R.
Okay. Wouldn't u1 times r give you 2?
Yeah.
Okay. So 10 is equal to u1 times r. Which one do I want? u1 or r?
Is it?
U1 R.
Both should probably work, yeah. What am I looking for in my answer?
Those 3 cents.
We're going to need to find u1 and r by the looks of it. Okay.
Yeah.
Which one will I sub into this?
U1.
You want to sub in for u1? Okay. So that's 10 over r is equal to u1, you're right. Okay, so 10 over r is equal over 1 minus r is equal to 49. You happy with that?
Can we do the other one?
No, I'll pick this one now. It's just like, yeah. You could do me. Okay. This isn't too bad because I can just multiply this over here and multiply it here and it cancel. So I'm left with 10 over r is equal to 49 minus 49 ratios. Yeah? Yeah, fine. How do I get rid of this one below then? Multiply both sides by it? 10 minus 49, that letter, 49 squared. So it's going to quadratic. This is why there's not the possible values. Yeah, it's not possible value. There's a bunch of values probably. Because I see that's a quadratic.
Yeah.
Rearrange it to look more like a quadratic. 49
Minus 49.
plus 10.
Minus 49 r squared.
Am I right?
No.
Five.
Minus plus.
take,
No,
Like negative 49.
I brought,
yeah.
add it over here, subtract it over here. Oh, massive.
Wait, can we maybe turn that AC on?
Wait, I
On,
know.
yeah, sorry, the last class was too cold and you guys too hot. Yes. And this one doesn't really work. Okay, what have I got? Okay, let's try and factorize this.
It's
We're good.
7,
Did you do it already?
7 minus 5, 7 minus
You done it already?
2. No, I just guessed.
7, 7.
Minus 5 minus
5 is 35, and 2. And so that's 14 or so that's 35 of them.
2. I was correct.
And you are correct, sir. Well done.
Top, top.
What's the signs here?
Minus minus 6. I'll get it.
So the ratio is 2 sevens from this one, or it could be
Is he?
5 over 7. Both. Am I wrong?
No.
Okay, so there's 2 possible options, which means that we have to show both answers if we went to solve it.
Yeah, once he shows us, we're like,
So 10 divided by 2 sevens could be the first term. Yeah.
Indeed.
And there's a second option for that. It could be 10 divided by 5 sevens. Could be the first.
But if there are 2 options for the first, what? Should there only be one answer for the first term?
No.
Oh, it's not. Oh, yeah.
Two answers for the same answer for the second term means that one is going up and the other is going down, let's say, and they've just met in the second term,
Yeah.
and that's probably the only one they'll ever share.
Wait, so is there 9?
How do I divide 10 by 2 sevens?
Keep chain flip.
Times 7.
70 over 2, 35.
35 could be U1 or
That's
14.
75 by
14 could be U1. Okay. What's U3 then?
5. U3 is, what was the second term? 10.
So it'll be 10 multiplied by,
2 over 7 or 5.
this will be 10 multiplied by 2 over 7 now, because we divided by 2 over 7 the last time.
Yeah, what's the second time?
It'll be 20 over 7. Just won't bother. And this is 50 over 7. Okay. How did I get those? I did the 10 by 2 over 7 and 10 by 5 over 7 to get this. So the next term would be multiplying by the ratio, the one backwards divided by the ratio. Okay? Yeah, tricky one that. Anything else? Why is the 10 as well? The 10 was the key part of the question. The second term of the series is 10. So if the second term of the series is 10, to get the next term of the series, I multiply by the ratio.
you're going back to the first.
Yeah, to go back, I have to divide by the ratio.
Oh, that's.
Yeah, so I had the balance point 10 and then go back to 4 and 10. Yep.
Question 25 for A, please.
25.
For A.
Oh, in the back in the other. Okay.
Go back to 4A. Yeah. I don't like this one.
This one?
Yeah.
This one?
Oh, yes. Yeah, yeah.
25? 24.
25, sorry.
25.
I was definitely doing something wrong.
What if you look at some point
Look, what I was 72x cubed minus 100 equals x squared. I was definitely in the wrong place.
Oh wait, I think I also tried to do it regular. I rubbed it out. No,
Like, I'm not doing
Right.
it.
No,
What the hell is convergence?
Yeah. Oh,
Wait, why do we need to say how to say
Yeah, I was like,
I know how to do that's a short answer. You don't. Yeah. Yeah, so don't worry about it too much. Just know how to apply it in a simple example.
And that other one you showed us with the formula being n minus 3 over n minus 4. So
Yes, yes.
that's just the same thing.
Yes, I was just showing that letter doesn't matter. The process is the same. Okay, I put pluses because it says series.
Yeah,
A convergence series, what the hell is that?
I have no.
What's a convergence series?
Oh, it's like when it
When it touches, guys.
Oh, but the 2.
Is it a quadratic? 2.0?
It's another way of saying something we've already done.
Intersection.
Not intersection. The series will converge. converged. So what series?
Is it a series where it kind of repeats?
No.
Asymptotes.
No. It's, yeah, limit. So it converges towards a limit. So it's a sum.
Okay, you also.
So it's converging. It means series usually diverge. They go to infinity. They go higher and higher.
Yeah.
This series converges. So instead of as it grows, it actually goes towards something.
Asymptote.
Oh, we've done this before. We've done this already.
Yeah, we done the
When we add, when we add,
Limit proportionality, that's something else.
that's converging.
Yeah.
It's converging towards a certain number, 64, isn't it?
Oh yeah.
Because we're adding together and converges.
Wait.
Those series add too much. What can I say about the ratio of this series then? Because this series converges as well.
Dividing.
It's a division, yeah, it's a fraction. Yeah. So that's the information of convergence.
Okay, so they're just saying of a
I got that too.
that R is going to be something to do with division.
So that means also we can use which formula?
The
Geometric.
Right.
Yeah.
I don't know that they can't count.
Oh, it
would be
infinite though.
It is infinite. Converges.
It's always
Because if the ratio is a fraction, then every next term is smaller than the last.
Every sequence is
And when you
Yeah, it's
add
a
up something smaller and smaller and smaller, eventually the small bit doesn't matter, and it was those initial terms that matter to it. That equals 18 over 7.
No, 18 over 7. Yeah, it's equal to u.
Isn't every sequence infinite unless that's
That's the
The sum of the sequence will be infinite.
No, the sum of this, so this, oh yeah, remember, I was talking about Cert.
So the sequences will go on forever unless you tell them to stop. And usually a series, the sum will also go on forever, except for when it converges or it's a sum to infinity, it's called the zero. Right, so we know this. The only way it can converge to a single answer is if the ratio fits this. It's between, it's a fraction. So instead of writing this on this side, I know what the answer is. I know the answer is 18. 18. Okay. Yeah? From the question. The sum of the series is 18 over 7.
When you do this with a root, like, does it matter which one the sequence is?
Arithmetic sequence won't converge. And it's only one.
It's like
It's going up by a certain amount.
It's a line, yeah? So arithmetic sequence, the line is just going to go off the same steady rate wherever it's going. If you keep adding those terms, there's no reason why
Oh,
it's,
it's not.
why it would ever, yeah, there's no reason why it would start turning, it's come back to even out in any way. It's just going to shoot off. They'll never merge.
And what is convergent?
It's this.
So linear.
Yeah, you would have dealt with like asymptotes going towards something.
Yeah.
So if you keep adding, a series.
It never touches.
Yeah. There was that thing where I walked across the room and I kept going multiplying by half my distance. It never got to the other side, but it converged over there. That's where I
Oh,
use
so convergence is where it gets to the point where it's like,
if you just say, well, you know what, that's the limit.
yeah.
We're going to say it's 64.
But a line will still repeat on a what, right? For a geometrization, even for one that
If you looked at it, it would look like a curve. It would look like this.
There's not any single line through that. Or is it when it goes?
And eventually the output values will just be like 0. And what's the point of keeping adding the output values?
Yeah, fair enough.
Then ones that start really matter. Like the ones that start, oh, this one's at 32, this one's at 16, here's at 16. 1, 2, 3, 4, 5, and all of a sudden you're just adding decimals. Every point you're going to get here is going to be a decimal.
Yeah.
Like, what's the point?
Oh, is that what you're doing? Compound interest?
Yeah, the compound interest will reach, also reach the limit.
Yeah.
And it'll reach the limit going this way a little bit.
Everything to do with
Reach
multiplication.
this limit at 2.7. Okay. It's all interlinked. It's all interlinked.
just a little bit.
Wait, but this can only be used if R is below 1, right?
Fraction. If 4 is -3, it's just more even. It has to be a fraction. Okay.
Could you please erase it?
Is it going in?
Yes.
No, you should have left like a time.
Right on that. Okay, we need to be able to solve this. We've got enough to be able to solve this. First of all, I don't want U1, I don't want this letter, I want these, I want an x's. I want both these written in terms of x, so I can have one equation with one variable.
2x over 1 minus
So, that's definitely 2x. And what's the ratio?
x minus 2 over 2x.
X minus 2 over 2x. You happy with that?
Yeah.
So I can replace this. Now this is not particularly nice to solve, but we can solve it. We can do it. If you like the term cross multiply,
Wait a minute.
the ratio, this is the first term, this is the second term. The ratio geometric sequence is always the second term divided by the first term. If we go 2, 6, 18, I can just find, I know it's multiplying by, the ratio is multiplying by 3, but I can find it by just doing 6 divided by 2, or 18 divided by 2. Okay, so let's just do a cross multiply. Although I don't like the term. Or that would start me off. This is solving algebra. How good we are.
Oh my god. I messed up on the first step.
We're saying possible.
And I didn't complicate it.
Okay, so that would be 18 minus 18 times x minus 2 over 2x is equal to 14x. I'm going to get rid of the 2x. Maybe multiply everything by 2x. 36x.
How'd you get there?
Oh, did I?
How'd you get there? No, I didn't.
Multiply 18 multiplication in here.
It's 7 times 7.
I tried.
Oh,
Now obviously this, I don't know if you want to cancel this now, 18 and 2, be 9.
No.
Don't bother? Okay, that's 15.
R has to be
Multiply this, only the 18s multiply this. Yeah, my half
Everything got
minus 18x plus 36 is equal to 14x times 2, 28x.
squared.
That's pretty cool.
And another quadratic.
Yeah.
But that's so important.
So it's 18x.
28x
Squared
squared
should be called like a
Plus
minus 18x.
So it's been plus.
I'm going this side. I'm going
Oh,
this
okay.
side. And then
Plus
minus 36 equals 0. And then I'm going to divide by 2. I can definitely divide by, make it a little bit easier. 2. Oh, so 14x squared minus 9x minus 18. Okay, we have to just factorize this.
Wait, hold on, let me try. We got.
How about factorizing this? Richmond? Come here, let's use it. It's a hard pass in Richmond. 6 and 3? Will that work?
No.
Yeah,
I think this is going to work.
yeah.
21x, 12x, minus 9x, minus and still, I didn't go with 9 and 2, too far apart. Trial and error. That's 12x. This one has to be minus, plus the minus. So we got 7x plus 6 equals 0, so x is minus 6 sevenths, and x is 3 over 2. I forget the question.
It was a sequence question, but here we are.
Wait, it says finally one back.
Well, one must not work. This is where
I got the password.
Oh, clearly explaining why there's only one possible value. No, the 2 things right. I didn't need to write the 2 there. If your length equals to 0, the 2 will only matter if you're drawing it. you can see because the roots would be the same, right? Remember?
Yeah, I get it, yeah.
Okay, why is one wrong? Why is one right? Which one's right? Which one's wrong?
I have no idea.
But only two ones.
I gave up before this.
Has to be positive because there's no negative in the all.
Okay, could be. Yeah, negative one. Well,
Oh, there is.
one condition for a sequence to converge is the only
Division.
or has to be a fraction.
Yeah.
So let's see does either of these not make it a fraction.
3 over 2.
Oh, X.
So we look at this, and this has to be a fraction.
Yeah.
So
So it has to be.
let's do 3 over 2 minus 2 all over 2 times 3 over 2. This one was the easier one to work with, so I'll do that first. So 1.5 take away 2,
Negative half.
negative half. And 2 times 3 is 3. What's that?
Negative 3 over 2.
So over 1 came here.
Wait. No, negative 1 over 6.
Yeah. Negative 1/6. Okay. The other one?
We're still on the same question.
Yeah, so we have 2 answers for x, and the reason we're still going with it is because it said find x, and then it said clearly explain why there's only one possible value. So we've got 2, so we have to figure out which one's right, which one's wrong.
I don't like this question.
No, this is a long process, no doubt.
Suck it up, butter it up.
No
Are you gonna throw it into a fat again?
Okay,
That's not. That's not.
what's this?
Minus
Hey.
Mine just say minus 2 and 6/7 for now. What's this?
6. Negative 6.
That's a 7. That's a 7.
Oh.
Negative 12 over 7. Okay, I'm gonna have to keep finishing. What's this? What's this? Is a
Negative 20 over
proper fraction.
No.
Negative
20 over 7.
Negative 8.
negative 20 over 7. This one's negative 12 over 7.
Oh, yeah.
Already you see it.
But
You
then
see
you
it.
have 6. I'm like, or am I?
7 times 2 is 14. And 6 is 1.
You go from
What's the
six
problem?
minus
7's cancel. The
That's
negatives
four.
cancel.
That's
That's 20
one.
over 12 is greater than what?
1.
Yeah.
This one
3 over 2.
wouldn't give, wouldn't convert. It would just keep in there and raise up to 2.
Wow.
That's
One
a
of
lot
those
of process.
So like every.
That's the second last question in the chapter. So it's
Wait, will everything to do with getting closer to infinity be quadratic?
If we want to ask unique questions, how long would that take?
huh? That should take you about 6 to 10 minutes.
Yeah, but we
I
make
did not see
mistakes.
this.
I didn't think of that. That was good.
We make mistakes, so like.
And I didn't even get it right.
You follow the process through. I don't think the theory is too. Once you figure out about convergence, you can use this formula for
Yeah,
convergence.
it's not too good.
Once you figured out this, you're okay. I think you can.
Yeah, once
and
you
you
figure
have
Can I
this.
ask one question for the other one? For when it's not infinite? I mean, when it is, I mean, when it's. Oh, for a, arithmetic one.
Yeah.
What's the formula for it?
The sum of the arithmetic
Yeah.
sequence. It's in your formula book. There's 2 of them.
No, but there's one question I asked for it.
Okay.
What was it?